Hello everyone, it's your favorite chemistry game, Adrenaline, the Bazooka Prophet. Today I'm going to be teaching you a very interesting aspect of chemistry, talking about the calculation involved in equilibrium, as you can see right here on the board. And in this video, I'm going to be taking my time to break every point that you are going to be needing in solving questions that involve uh, 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 equilibrium constant and the the change in concentration of them. And as you can see right on the board, I'll read out the questions for you, then we'll start solving immediately. So the question says at 440 degrees Celsius, the equilibrium constant for the reaction, which is hydrogen reacting with iodine to give us hydrogen iodide, is 49.5. That is to say that the equilibrium constant for this reaction that you can see right on the board is what? 49.5 if 0.20 mole of hydrogen and 0.20 mole of iodine are placed into a 10 dm cube vessel and permitted to react at this temperature. What will be the concentration of each substance at equilibrium? It means if I was given the substances involved, such as hydrogen iodide, iodine, and hydrogen, if I was given the concentration at equilibrium, there will be no need for me to be going through stress. I'll just plug into the formula, then off I go. Now, the first thing for us to do is to bring out the reaction, which is H2 plus I2 at equilibrium give me hydrogen or iodide. Now, that's something that you must know. Now, the first thing for us to do is to understand these three methods, which we call I's. I's. The I stands for the initial concentration. The C stands for change in concentration still, and E at equilibrium. If you can understand them, it's very simple. Now, the first thing for us to do, first thing is to get the concentration of the iodine and the concentration for the concentration of the hydrogen and the concentration for the what now? Iodine. And we'll do so, we'll be having it here. We're having the concentration of the hydrogen. Remember, concentration is what now you know that is C is equal to number of mole over the volume. And the number of mole here for the hydrogen is 0.2 divided by the volume, which we have here, for given to us to be 10 dm cube vessel, which is 10. And when we divide it, we have it to be 0.020 molar concentration. Move straight down to iodine, still the same, 0.20 divided by 10 will also give us 0.020 molar what? Concentration. Then we'll move straight to the formula. Please, it is not difficult. Already you are aware that the equilibrium constant is equal to the rate of the forward over that of the what now? The reactant. The reverse. So here becomes the hydrogen iodide. Remember, this mole will form the power over that of the hydrogen and that of the what now? The iodine. Very, very simple. Then we can start. Remember, from the initial, which is the I, the initial, we're having the concentration of hydrogen here. Please follow me, because I'm going to be giving you a step by step approach that when you see related question, you will be able to solve it without stress. As I've always told you guys, that chemistry for A level and even O level are not difficult. They are not. Just follow suit. For every question on earth, there is a solution to them. Pay attention to the basics and rudiment, and off you go. You understand? So let's move straight away to God. And we were given the concentration of hydrogen from the initial, yet was 0.020, the iodine 0.020, but that was the hydrogen iodide. You weren't given at all, so you have become what now? Dash. I will move straight down to the change. The change, which is also in concentration. Please take note here. Now, in the case of the reactants that are depleting, we assume and the depletion here should be what now? X. Yeah. Iodine 2, X. But that of the hydrogen iodide will be what now? 2, this mole here, 2 what? X. Now, but because this product, because product is being formed, you get me now? Yes, takes a positive sign. Why that of the reactor? Because they are depleting, because they are being consumed, it takes a negative sign. Please take note. The reverse often take negative signs, while the product form take positive signs. Then we now move to the equilibrium, which is E now. You see eyes. That is how it is. So at equilibrium now, together they become 0.02 minus x. Let's still become 0.02 minus x. Why? Here, because there's nothing here, it comes down. It becomes 2x. This is what I am interested in. Or this is what I'll be plugging into this. Is that clear now? Now, we were given our KEQ from the question to be what now? 49.5. So it become 49.5 is equal to, follow me, that of the hydrogen iodide now, which is this one now, will now be 2x, right? Then close bracket, then square for what you have here. Please follow me. It's simple. Move straight down here. For the concentration of the hydrogen is concentration of 0.020 minus x multiplied by 0.020 minus what? X. You see how easy it is to close bracket. Very simple. Now, please follow me. Now, we can as well also come here to say 49.5 is equal to 2. See now, 2x raised to power 2 over these 2 can be written mathematically as 0.020 minus x raised to power what now? 2. See, you can do it anyhow you want to do it, you still get your answer. So it is not difficult at all. So I will have to clean some part now. So I will have enough space. Please, this one, get it clear and straight. Yeah, I will have to clean this one now so we can now start. Okay, when we get here, please follow me. Here is 49.5 is equal to, I can write this one in another format in such a way that I will take what now, if I could taking the square root, of what you have here of this left hand side and this right hand side, I'll be having it to be, so that when I take the square, remember, the square root simply means times 1/2 times 1/2. This one, that is raised to power, you see now, 1/2. It is very, very simple. So the square root of this one now will give me what now? Let me, okay, will give me 7.035 equal to, remember this one will definitely cancel this one will also cancel this one, so I'll be having to be 2x over 0.020 minus what now? X. See, it's now in its plain form. So what do I do here? I cross what multiply. So here become 7.035 bracket 0.020 minus x is equal to what? 2 what? 2x. So we go. When we multiply, so we open bracket. Please follow me. It's not difficult. So yeah, we have here 0.1407 minus 7.035x is equal to 2 what? 2x. What do? I collect items. Normal mathematical what? Normal, please take note of this. Normal mathematical what? Approach. So what do? So here become 0.1407 is equal to 2x plus 7.035x. So here become 0.1407 is equal to 9.035 x. So x here is now equal to 0.1407 over 9.035. When I do so, I'll be having to be what now? 0.016. That's molar concentration. So I'm cutting for the x now. So when I now come here to get for the concentration of each substance at equilibrium, which is that of the H2, which is 0. Okay, which is 0.0 what now? That's okay, 0.02 minus the x. Remember, this x here, or sorry, this x here, which we have gotten to be 0.016, we give me 0.0. Let me not make any mistake. So that's 0.04 molar concentration. That of the I2 also give me 0.020 minus 0.016 0. molar concentration. Then to get for that of the hydrogen iodide, which is 2 multiplied by 0.016, you 0. Okay, and that's 2 times 0.016 times 2 in 0.032 molar concentration. And on that note, we come to the end of this part. Please take note. You see the way of this up. First step, bring out the equation. Second step, you already know that the concentration given to us from the initial that you have here, 0.02 mole, convert it to concentration by dividing by 10. You get each of them here. So you give for this, give for this, but you're not giving for this. The change, I've told you, depletion, take negative of the concentration, negative of the word concentration, then 2x because of this 2 mole here. So we come down here, we have come here. Now, you can do it in so many ways. And you can also do it in such a way that it will be in a linear, like it will be in a quadratic equation. So right now you do it, just make sure that you do it carefully, not to make any mistake. For now, I remain my humble self, Adrenaline, the Bazooka Prophet. God bless you.